Hello everyone, my name is Jessica Acosta. I'm a graduate student in the Monogastric Nutrition Laboratory at the University of Illinois, and today I will talk about a research where we determined that corn protein has greater digestible amino acids and energy than low-oil distiller dry grains with solubles when fed to pigs and may be used in diets for weaning pigs. Corn protein is a co-product from the dry grain ethanol process, as distiller dry grains with solubles or DDGS. It is obtained from DDGS by maximized stillage co-products MSC technology. In this technology, the whole stillage is separated into an insoluble fiber portion and a thin stillage portion using a filtration centrifuge. The thin stillage portion is separated into a protein portion and a water-soluble solids portion. Then, the protein portion is dried to define a high-protein corn meal. Corn protein is characterized for having 50% protein on dry basis and having improved amino acid profile compared to other corn-based products. In addition, corn protein contains up to 20% yeast. Those characteristics could affect energy and amino acid digestibility and have implications in terms of growth performance. However, there are limited information about the nutritional value of corn protein. Therefore, the objective of this research was to test two hypotheses. First, we tested that the standardized ideal digestibility of amino acids, as well as the concentrations of digestible energy and metabolizable energy, are greater in corn protein than in DDGS when fed to pigs. Secondly, we tested that corn protein may be included in diets for weanling pigs at the expense of other protein sources without reducing growth performance. Let's move on into the materials and methods. For experiment 1, we wanted to test amino acid digestibility. Therefore, we used 8 growing pigs with 37 kilograms of body weight in average that had installed a T cannula in the distal ileum located in individual pens. We used a replicated 4x4 Latin square design with 4 periods and 4 treatments. We formulated 4 diets using each of 2 sources of DDGS, 1 or 2, or corn protein as a sole source of amino acids in the diet, and a nitrogen-free diet to determine basal endogenous losses. Each diet had 0.4% of chromium oxide as an indigestible marker. We used periods of 7 days. The first 5 days were the adaptation period, and the last 2 days were the collection period. We collected ileal digesta and analyzed for amino acids. We made the data analysis using prog-mix of SAS with ingredient source as fixed effect and square period and animal as random effects. For energy measurements, our experiment number 2, we used 32 pigs with 17 kilograms of body weight in average, located in individual metabolism crates. We allotted pigs to 4 diets using a completely randomized design. We formulated 4 diets, 1 just with corn and 3 diets containing corn and its source of DDGS or corn protein. We used periods of 10 days. The first 5 days were the adaptation period, and the other 5 days were the collection of feces and urine period. We made the statistical analysis with prog-mix of SAS using ingredient source as fixed effect. Moving on to growth performance, experiment number 3, we used 160 newly weaned pigs in a completely randomized design. There were 5 pigs per pen for a total of 32 pens. We used a feeding program with 3 phases. Phase 1 diets were fed from day 1 to 7, Phase 2 diets were fed from day 8 to 21, and the Phase 3 diet was provided from day 22 to 35. In Phase 1, the control diet contained 5% HP300, an enzyme-treated soybean meal, and 2.5% plasma protein, without corn protein. Two additional diets were formulated by replacing either plasma protein or HP300 by 5% corn protein, and one diet was formulated by replacing both plasma protein and HP300 by 10% corn protein. In phase 2, the control diet contained 5% HP300 without plasma or corn protein. Three additional diets were formulated to contain 2.5, 7.5, or 10% corn protein at the expense of HP300. The common phase 3 diet was based on corn, soybean meal, and 10% DDGS. We weighted out the pigs and the feed left in the feeders at the end of each phase, and we recorded the feed additions daily. Data were analyzed using proc mix of SAS with the pen as the experimental unit and diet as fixed effect. Let's move on into the results. I'm going to start with the nutrient composition. Before, I would like to set up my slides. DDGS1 will be presented with blue bars, DDGS2 in orange, and corn protein in yellow. We observe that corn protein has greater concentrations of crude protein and less total dietary fiber and fat than DDGS1 and 2. Besides, DDGS2 has greater concentrations of total dietary fiber than DDGS1. It is important to mention that both sources of DDGS have a concentration of fat of 8%, therefore are considered as low oil DDGS. When we look at the digestibility of amino acids, we observe that corn protein and DDGS2 have greater standardized ileal digestibility (SID) than DDGS1 in most amino acids, with the exception of methionine, where corn protein has less SID than DDGS2 but greater than DDGS1, and tryptophan, which was not significantly different among ingredients. However, when we look at the concentrations of digestible amino acids calculated by multiplying the concentration of each amino acid by the SID, corn protein has greater concentrations of all digestible amino acids than DDGS1 and 2. Moving forward to energy concentrations, corn will be presented with green, DDGS1 in blue, DDGS2 in orange, and corn protein in yellow. Corn protein has greater kilocalories per kilogram, followed by DDGS2, DDGS1, and corn in descending order. However, corn protein had greater digestible energy and metabolizable energy than corn, DDGS1, and DDGS2, likely due to greater concentrations of growth energy, crude protein, amino acids, and less fiber in corn protein. Moving forward for the growth performance results, for phase 1, the control diet will be presented with yellow bars. Diet with 5% corn protein and plasma will be in light blue. Diet with 5% corn protein and HP300 will be in orange, and diet with 10% corn protein in dark blue. During phase 1, the average daily gain was greater in pigs fed the control diet and was less if corn protein replaces plasma protein and both plasma and HP300. Likewise, pig fed the control diet had greater gain to feed ratio in phase 1 compared with pigs fed the diet containing HP300 and corn protein, and the diet containing 10% corn protein. We observed the final body weight at the end of phase 1. Pigs fed the diet with HP300 and corn protein, and the diet with 10% corn protein have less final body weight than pigs fed the control diet. It indicates that pigs fed diets containing corn protein had reduced average daily gain, gain to feed ratio, and final body weight at the end of phase 1, compared with pigs fed the two diets containing plasma protein and HP300. Therefore, corn protein cannot replace plasma protein or HP300 in the first week post-weaning without negatively affecting growth performance. However, when we look at the average daily gain of animals fed 0% corn protein during phase 1 and phase 2, yellow bars, 5% in phase 1 and 2.5% corn protein in phase 2, light blue, 5% in phase 1 and 7.5% in phase 2, orange, and 10% in both phases of corn protein, dark blue, the average daily gain during phase 2, phase 3, and the overall experimental period was not different among treatments. Likewise, the gain to feed ratio during phase 2, phase 3, and the overall experiment also was not different among diet treatments. The average daily feed intake did not differ between pigs fed the different levels of corn protein at any phase and in overall. However, when we look at the final body weight in phase 2 and 3, a tendency for reduction in final body weight is observed at the end of phase 2. However, at the end of the overall experiment, the body weight did not differ among treatments. Therefore, the observation that growth performance did not differ among treatments for the overall experiment indicates that protein utilization and growth performance are not affected by inclusion of corn protein in diets for nursery pigs after week 2. Let me summarize what we have discussed. Corn protein has greater concentrations of crude protein and standardized ileal digestible amino acids than in two sources of low oil DDGS. The concentrations of gross energy, digestible and metabolizable energy in corn protein are also greater than in corn and low oil DDGS. Pig-fed diets containing corn protein had reduced average daily gain and final body weight during the first phase of the experiment, but inclusion of corn protein in diets did not affect growth performance in phase 2 or overall. Therefore, corn protein may be included in diets for weanling pigs by up to 10%. With that, I would like to appreciate Flynn Health Resources for supporting this experiment and my team members for supporting me. Thank you for listening.